Welcome back, dear grade 9 students, to more and more ideas about plane geometry you need to know. Now we have to talk about a property that's in a circle concerning the chord and the perpendicular drawn from the center of the circle to that chord. So as you see in this figure, there is a circle C of center O, and OM is the height, or what we call the perpendicular or the altitude, drawn from this center to that chord AB. We notice that M is gonna be the midpoint of that chord, i.e. that OM, that height, is gonna be the perpendicular bisector of that chord, and here is the proof. Since OAB, if you join O to A and O to B, we are definitely getting an isosceles triangle because OA and OB are radii and definitely they are equal. So we have an isosceles triangle OAB, and as you know, in the isosceles triangle, any height relative to the base from the vertex of that triangle is going to be also a perpendicular bisector to that base, and it's also a bisector of the vertex. So that's the property of the isosceles triangle, and thus OM is a perpendicular bisector of AB, M is midpoint of AB, and if we continue drawing and that OM intersects the circle at point N, then this point N is also a midpoint of the arc AB. Thus, arc NA and arc NB are equal. So to sum up, in a circle, the perpendicular drawn from the center to a chord in a circle is also a perpendicular bisector of that chord. Let's continue and see what more ideas we have. Also, we are going to talk about the length of an arc. So in a circle, if we have as follows, a circle of center O and radius R, and here is the arc AB, and here is the central angle AOB facing that arc. If we have the measurement of that angle, then we have the measurement of that arc in degrees. So to find the length of that arc, we use this property. 360 degrees, which corresponds to the measurement of the circle in degrees, is corresponding to 2 pi r, which is the perimeter of the circle or the length of the circle. So the perimeter of the circle is represented by 2 pi r, is given by 2 pi r. Then to find the length of the arc AB, all what we do is to write the measurement of that central angle facing it under 360, and this is the length we are going to find. So by cross multiplication, we are going to get that length is equal to 2 pi r times the measurement of the central angle facing the arc, or the measurement of the arc itself divided by 360. If you don't want to memorize the property, it's not a big problem. So you just have to use this way and just cross multiply. So degrees under degrees, here is the measurement in degrees, and here is the length of the circle, and here is the length of the arc. Now, here is a training exercise on that idea. If the radius here is equal to 2 centimeters, suppose that the radius is 2 centimeters and that alpha, the central angle, is 60 degrees, we have to find the length of that arc AB. So we use this method. As I told you, 360 corresponds to 2 pi r, then 60 is corresponding to L. L is the required, so L equals 2 pi r times 60 degrees, so 2 pi times 2, because r is 2, times 60 degrees divided by 360, it is equal to 2 pi over 3 centimeter. Now conversely, if we have given the length of the arc and we have the radius, we can find the measurement of the central angle in degrees. So if the length of the arc is given in centimeter, because if the radius is in centimeter, then definitely the length of the arc is in centimeter. So if the length is given, then we are going to find the measurement of that arc in degrees, and the measurement of that arc is definitely equal to the measurement of this central angle facing it. So again, we use the same property or the same method. 360 corresponds to 2 pi r. Now here alpha is the missing and the length is given, so we put pi over 4 under 2 pi r, and alpha, the missing one, under 360. We cross multiply, then alpha equals 360 times pi over 4 divided by 2 pi times 3, which is the radius, and thus alpha is equal to, that's equal to 15 degrees. So by simplifying pi with pi and making some calculations, we get that alpha equals 15. Now, in the coming slide, we are going to talk about a new idea, also concerning the circle and its properties and the things inside a circle. Here we have to talk about the area of a sector. So the arc is just AB, while the sector is called by AOB. It's like the slice of a pizza. So this is a sector. What we mean by a sector is like naming an angle in 3 points, but it is a part of the circle. Now, to find the area of that sector, we use the same method we used previously, but here we are relating 360 degrees to the area of the circle, which is pi r squared. So we have to remember that the perimeter of a circle is equal to 2 pi r, and the area of the circle is equal to pi r squared. When we are dealing with length of an arc, we use the perimeter, and when we are dealing with areas of sectors, we use the area. So 360 again corresponds to pi r squared. Then alpha is the central angle, as I keep telling you, the central angle facing that arc is corresponding to the area of the sector. Now by cross multiplication, we get that A equals pi r squared times alpha divided by 360, where alpha is the central angle. So if we continue, we will get a training exercise here, training example, using this method. If the radius of this circle is equal to 2 centimeters, and the given alpha is 60 degrees, and we have to find the area of that sector AOB, again we use this property, we cross multiply, so the area equals to pi r squared, means pi times 2 squared, which is 4, times 60 divided by 360, and the final result is 2 pi over 3 centimeters squared, because the area is measured in centimeters squared or meters squared or whatever, according to the radius. If the radius is in centimeter, then the area is in centimeter squared. Now conversely, if we have the measurement of the area, if we have the area that's equal here, for example, pi over 2, the area of the sector, and we have to calculate the measurement of the central angle facing that arc AB, all what we do is also to apply that rule, and thus we will get 360 is corresponding to pi r squared, alpha is corresponding to pi over 2. Again, we put the given under pi r squared because it's related to the area, and here the degrees together. Cross multiplication, we will get that alpha equals 360 times pi over 2 divided by pi r squared, which is pi times 9, and thus alpha equals to 20 degrees. So by this, we can calculate the central angle if we know the area of the sector.